Hello guys, this time I will go over Calculus 2024 FRQ question number 5. This one is really easy question, like as long as you do not overthink. So let's do one by one. So consider the curve defined by this equation here, and it is shown that dy dx is equal to this. So it's given to us. So there's a point on the curve near 2, 4 with the x coordinate 3. So do you see it has x squared and y squared? So probably this graph will look something like this, okay? But you don't have to really know about this. Use a line tangent to the curve at 2, 4 to approximate y coordinate of this point. So basically you really want to find the y coordinate of this, but keep that in mind. There's a magic word which is a line tangent, which means you just want to solve for y, but whenever you see use line tangent, it's going to be always y minus y1 equals mx minus x1. And the coordinate they gave us is the 2, 4. Well, it's really easy. Now, do we know y value? Yes, 4. Do we know x value? Yes, 2. Do we know the slope? No, but it's given to us right here, which is negative 2x over 3 plus 4y, but we're going to plug these numbers in, so negative 2 over 3 plus 4 times 4, which negative 2 times 2 is negative 4, 4 times 4 is 16, 16 plus 3 is 19. So this is y minus 4 equals negative 4 over 19, x minus 2. Well, you can simplify by just like distributing everything in the plus 4, but if I were you, I'm not gonna bother myself. I will just do plus 4 on both sides. I'll say y equals negative 4 over 19, x minus 2 plus 4, and I will just leave it like this because I will just let 8th graders, you do it. That's still perfect point. Let's do the B. It says, is the horizontal line y equals 1 is a tangent to the curve? So let's see if y equals 1 is a tangent. If it's a tangent, this graph should touch at, it's a y equals 1, right? So it should be 0, 1. So this graph should touch here like once, like only one point like this. So let's see if it is tangential to this point. Only thing that you really have to do is, do you see this original equation, which is x squared plus 3y plus 2y squared is equal to 48? Once you plug this one in, that should be equal to 48. That's the only thing that you really have to do, because if they are not equal to each other, they're not even tangent, okay? So let's see if they are equal to each other. I'm going to plug in 0. Plus 3 times 1 plus 2, 1 squared, and see if it's 48. You can kind of already tell 3 plus 2, 5 is not equal to 48. So I can clearly say this is not tangent. So you can say since 5 is not equal to 48. If you don't know what to write, just write it down. Wait a second. Horizontal line y equals 1 is not tangent to the curve. That's it. Well, it's rather easy. Let's just see. The curve intersects at positive x-axis at point square root of 48, 0. Is a line tangent to the curve at this point is a vertical line? Oh, vertical. So we want to see if it is a vertical line, which means undefined slope. So to be undefined slope, I don't really care what you have as a numerator, but denominator is going to be equal to 0. So let's see if it's going to be this case. So we already know our slope is right here. Again, it's right here. It's going to be dy dx equals negative 2x over 3 plus 4y. Let's see, I don't really care about the top. I mean, you can just plug in square root of 48. I don't care. Let's see if denominator becomes 0. So I'm going to plug in 0. But as you can see, on the top, -2 square root of 48. But in the bottom, 4 times 0 is a 0. But I still have a 3 plus 3. So I will both say 3 plus 4y, which is this denominator, is not equal to 0 at point square root of 48 comma 0. Therefore, the line tangent to the curve at this point is not vertical. That's it. It's really easy. All right, so let's do the last part of question number 5. It's a particle motion. Great. Be careful. It's a t greater than or equal to 0. So it's not x and y. It's a t. A particle is moving along another curve as defined by equation this. Okay, so another point. It's not this equation. It's a new equation. At an instant, the particle is at the point 4, 2. So it's at the 4, 2. The y-coordinate of the particle's position is decreasing at the rate of 2 units per second. So it says decreasing for the y-coordinate, right? So it's dy dt because it's decreasing. So particle's position is decreasing means its slope is decreasing is equal to -2 because it's decreasing at an instant. And what is the rate of change of the x-coordinate of the particle's position with respect to the time? So particle's position with respect to the time. So basically, we want to find dx dt. So let's write it down. Y to the third power plus 2xy equals 24. And what we know is that dy dt is equal to -2. And at what? With a 4, 2. So let's do this. Oops. So when you take a derivative with respect to t, this one is 3y squared times dy dt plus, when you take a derivative here, keep that in mind, f is 2x, f prime is going to be 2 dx dt, g is equal to y, g prime is dy dt. So it's a product rule. I'm not going to explain the formula because you should know by this time. So f prime, so 2 dx dt times y plus f times g prime, so 2x times dy dt equals, so we finished taking derivative over here, derivative of 24 is equal to 0. So in my opinion, only difficult part is only this one, like you taking derivative of this. All right, so let's plug in what is given to us. Instead of y, I'm gonna plug in 2. Instead of dy dt, I'm gonna plug in -2 plus 2 times dx dt. I don't know what that is, but I know y is equal to 2 times dx dt plus 2 times x is 4, dy dt is -2. That should be equal to 0. So instead of like each variable, I just plugged in the number. This one, I just put it at the end because that looks nicer. Only thing that you have to do is to solve for dy dt. I believe this one should be easy. Just be careful with the sign. 2 squared is a 4. 4 times 2 is 8. 8 times -2 is -16. Plus 2 times 2 is a 4 dx. Oh wait, this one is a 3. Why is it? Okay, so never mind. because I forgot about this 3 here. 2 squared is a 4. 4 times 3 is 12. 12 times negative 2 is negative 24. Nice catch. Proud of myself. Plus 2 times 4 is 8. 8 times 2 is negative 16. So it's not plus, it's negative minus 16 is equal to 0. Well, I'm going to do plus 24 plus 16 plus 24 plus 16 right here. That disappears. So I'm going to put 4 dx over dt is equal to 24 plus 16 is going to be 40. And if I divide by 4 on both sides, dx over dt is equal to 10. That's it. I think this one is like really easy. So again, in question number 5, even if you don't know many things, I believe you guys can figure out some of this one. At least you can do this one. This one, I'm not really sure if you're not really sure about this, but even if you cannot do this question and these questions, I believe you guys can do this question, okay? So even if you don't know how to do C, B, and C, that does not necessarily mean you cannot do D, okay? Because this is not, like any of these questions are not relevant. All right, so let's go to question number 6. Oh, well, this is easy, I believe. All right, so A, we got 2 things. The function of f and g are shown here. So do you see f? That's an f. Do you see g? This is a g. As shown on the graph. Let R be the region bounded by blah, blah, blah here, where x from x equals 0 to x equals 2, as shown in the graph. Right, but do not evaluate an integral expression to given. Oh, so we just want to find this one from 0 to 2. What is it going to be? Like for area under the curve. It's very simple. You just do antiderivative from 0 to 2, because that's what question is asking. Always top minus bottom. Top is f of x minus g of x. Okay, so this is gonna, I mean, I believe you guys can just leave answers like this. I think this is gonna be still considered as an answer. Yeah. Oh, I forgot about dx. But if you want to make sure, you can put 0, 2. F of x is x squared plus 2 minus g of x is x squared minus 2x dx. And if you write like this, you're wrong. Don't forget, do you see this negative and g of x? You gotta put parentheses for this one, okay? Because if you do not put parentheses here, you're wrong, because this negative will impact this and that. So either leave it, no, actually do it like this, or distribute ahead of time, okay? All right, so let's do B. Let S be the region bounded by the blah, blah. Oh, so now we're gonna do from 2 to 5, showing the graph. Region S is, oh, now it's gonna be rotation, solid. For the solid, its x-axis section perpendicular x-axis is a rectangle. Okay, so I'm gonna draw the rectangle with a height equal to half of its base. Okay, so if this is x, this one is 1/2 x. All right, so area of the rectangle is base times height. So in this case, x times 1/2 is 1/2 x squared. In this case, this x squared means this entire thing. So keep that in mind. So let's do this. Antiderivative, now this time is going to 2 to 5. So I'm going to put 2 to 5. As I said, always top minus bottom. In this particular case, top is this, g of x. So you're going to write g of x, which is x squared minus 2x. Minus, bottom equation, do you say this one is nothing but 0, y equals 0? So you can write down 0 if you want to, but you don't have to. And dx, that's about it. But again, you're going to rotate it. It's going to, not rotate, it's going to be the solid with a rectangle, right? 1/2 x squared. So what you're going to do is, let me use another color. This squared with a 1/2, because rectangle is base times height. And in this particular case, area base is x, height is 1/2 x, which means area is 1/2 x squared. Keep that in mind. All right. And did it say to evaluate? It did. Dang it. Okay, so I thought that was it. Okay, so let's evaluate. 1/2. Keep that in mind. This one minus 0, we don't care. So do you see this squared? This one does not go right here. First, you have to write down x squared minus 2x, x squared minus 2x dx. Let me erase this like this, okay? So that it looks better. Well, when you do this, keep that in mind. X times x squared is x to the 4th power. X squared times negative 2x is a negative 2x to the 3rd power. Negative 2x times x squared is negative 2x to the 3rd power. Negative 2x is a positive 4x squared. So this is same thing as 1/2 2 to 5. Wow. X to the 4th power minus 4x to the 3rd power plus 4x squared dx. Because I just combined these two if you don't know where I got the negative first form. All right, let's take an antiderivative. So I'm going to write 1/2 plus 1, so it's going to be x to the 5th power over 5 plus 1, so minus 4x to the 4th power over 4, which 4 will cancel out, plus 1, so plus 4x to the 3rd power over 3 from 2 to 5. When you actually evaluate it, it's going to be, by the way, I'm going to cross that out. Well, if you want to simplify, go ahead. Minimum requirement that you have to do is you have to do it like until here. 2 to the 4th power plus 4. Oh, wait, why did I put 2? 5. 5 to the 3rd power over 3. I'm going to put parentheses here. Minus, I'm going to do the same thing. 2 squared. No. Do you see my mistakes? I cannot believe this. 2 to the 4th power plus 4 2 to the 3rd power over 3. And then I'm going to close with a big bracket because of this 1/2. So keep that in mind. I'm just plugging these numbers to x minus this one to the x. Just make sure you gotta use parentheses. Otherwise, you're going to mess up all this sign. Just like here, okay? Now, do you really want to like simplify it? No, I don't want to. So I will just leave it like this. That's fine. That's totally fine. You still get a full credit. All right, the last question. C. Write but do not evaluate. Okay, I love this. Only thing that I have to do is to set it up. An integral expression that gives the volume of the solid generated when S, as described part B, this one, is rotated with a horizontal. Okay, so we're going to rotate this with a y equals 20, which means right here, y equals 20. You're going to take a rotation. Keep that in mind. When you take a rotate from here, this is 20. This becomes outside, right? And this one becomes inside. So how you like make things happen is going to look slightly like different. So let's do this, how things actually look. First, antiderivative of volume. Keep that in mind. Because you're rotating, it's going to be pi r squared. So it's going to be pi. Actually, let me put pi later. Antiderivative of 2 to 5. Again, first, because this one hits first, I'm going to write 20 minus 0. But do I really have to put 0? I don't think so. But I will just put it just in case, okay? So it's going to be 20 squared minus, now this one goes inside, right? So 20 minus, what's it called? Top, g of x. And that's pretty much s squared dx. Now, after that, keep that in mind. This one is what? what's it called? You're gonna rotate it, right? So you have to pi. This entire thing becomes your radius, r squared. Oh no. That's it. Pi r squared, because this one becomes your radius. So radius minus radius. That's what happens. Well, if it was not minus, I should have to do entire thing squared, but not in this particular case because there's a like empty space between here. That's why I gotta do this and this. All right, let's do this. Pi, we don't have to evaluate it, but let's do the minimum simplification. 20 squared is gonna 400, but if you don't wanna do it, you can leave it like this, I believe. But what you cannot do is 20 minus, you really have to write g of x. If you write like this, again, you're wrong because you have to put parentheses here, all right? Yeah, that's about it. Easy, right? So that's it. If you can pick up certain questions from this FRQ, I believe you're gonna be fine on FRQs. Make sure you study. Again, you don't have to be perfect. Just you have to know which one you can do, which one you cannot do, and try your best. Never give up. Write something with a confidence. Do not write any types of apology letters to graders because they're not gonna do anything else. All right. That's all right, guys. I love you as always. See you later. Bye.